so the next section then is to, and this is where it kind of breaks away from anything that you look on the internet and you're looking at chemistry stuff. They're going to be doing stuff differently than what we do here. So this is where it kind of starts deviating. What we've done so far is there's a lot of stuff on, let's say, concat, ketamine stuff in order to teach you that. This next step is automotive fuel, we'll call that related. So, what we're wanting to do is that since we're figuring out stoichiometric, 1 pound fuel. So what we're dealing with is that we have to get this to a 1 pound value. So what we say is okay, this number, whatever it is, equals 1 pound. Could be 1 gram, could be 1 banana, whatever you want to put it as. Okay, that's my reference number. So then I say, okay, if that equals 1, let's break this all down into 1 pound fractions. So what I do with that is I take the 60 and see how many times 60 will go into 224. And what's that number? So what's that number when I take 60 into 224? 3.73 pounds. Now I'm breaking it down into pound fractions because that's 1 pound. 60 equals 1 pound. So now that's 3.73 pounds. I do the same thing with my CO2. So I take 60, which equals 1 pound, divided into 176. And what's that number?
It's going to be like 2.9.
2.9 something?
4,
2.9. I like to try to get, when we do this, I want to try to get you guys to do 2 decimal places past, 2 spots past the decimal. So is it a 0?
It's going to be.
I'm giving it a 0. But then I'm going to take 60 and divide it into my 108. And what's that number?
1.0.
Say that again?
1.0.
1.0. 80. There we go.
2.93.
2.93, thank you. Okay, so what that means, if I take 1 pound of fuel, of ethane, it's going to produce 2.73, I need 3.73 pounds of air, 3.73 pounds of O2, which is going to give us 2.73 pounds of CO2 and 1.80 pounds of water. Okay, so that's how many pounds of water is going to be produced. Think about that. You know, that's how many pounds of water is going to be produced every time I burn 1 pound of this fuel. Questions under that step? Breaking everything down into 1 pound sections. I take 1 pound of fuel. I'm going to take 3.73 pounds of O2. It's going to then take, that's going to produce 2.93 pounds of CO2. Not a lot of CO2. You know, 20 pounds is a lot. This is not very much at all. Hardly anything compared to other fuels. And the water amount is 1.80 pounds of water is going to be produced. Yes, sir?
Are we always going to compare to 1 pound?
Yes, we are. And the reason is because, now, if we were living in Canada, we'd probably be in grams. But we're still using a unit of measurement of pounds, and that's typically what we tend to use a lot, so that's what we're going to do. Yes, sir? Someone have a question? Okay, so when I take a look at my stoichiometric, which figure out my stoichiometric, we have a problem though. Because my air-fuel ratio is air, not oxygen. And the fuel, when it burns in the air, it really only is consuming or doing something with the oxygen. The nitrogen hopefully is going in and going out and not really doing anything with this formula. So I have to figure out how much air I need, not how much oxygen, to convert it into stoichiometric. And so this is the difference. So what you have to know is, since we're comparing everything by weight, how much oxygen by weight is in the air? What's that number? 23%, right? 23%. 23.2% of air is oxygen when you weigh the air out. So what we do then is we say, okay, all this air that I have, about a quarter of it is all I'm really using. Okay? Okay, a lot of the air is not being used, you know, only a quarter of it, the oxygen, is what I'm really using in order for this combustion process. So what you do is you take and you say, okay, take 7.37, that's how many pounds of air, and go ahead and divide it by 0.232. So I'm going to change that from a percent, because right now that's a percent, 23%. So take your calculator out and see how many times.
16.08.
16.08, there you go. So, 16.08, so air to fuel ratio. The key is you gotta take this number, whatever you get right there, and you gotta divide it by 0.232 to come up with your stoichiometric ratio. So when you look at this, how would I compare ethane to gasoline? How would I say the air-fuel ratio is? In layman's terms, if you were talking to a technician, how would you explain that? Is it leaner or richer than gasoline?
Leaner.
Yeah, it's leaner. It has more air going into it than 14.7. So the higher the number, the leaner it is. The lower this number, the richer it is compared to our normal 14.7 to 1 that we're used to dealing with. Yes, sir.
So why do we use 60 as our reference to 1 versus?
Because that was how many atomic weight units this particular amount of fuel is. And that number is going to be different for every fuel that we do. We do hydrogen, we do gasoline, we do diesel fuel, we do propane, methane. That number is going to be different. And these numbers are all going to be different. And so I'm just converting this is going to equal 1 pound. I'm just doing a little bit of short math is what I'm doing. I'm taking some shortcuts. So I'm teaching you the shortcuts. You guys can go ahead and shut off the video.